So another example of solving a quadratic inequality, except this time now we have a non-zero side. Since it's a quadratic, we're going to have to at some point convert this to a quadratic equation to solve it. We do need to get a 0 on one side, so we subtract 12 from both sides. We can accomplish that. We get 2x squared minus 7x minus 12 is greater than 0. Factoring this is impossible at this point because we have 2x squared. If we were to try to factor it, we would have to divide everything by 2, but dividing that negative 7x by 2 would result in a decimal, which makes factoring not the best option here. In fact, the best option would be the quadratic formula to solve this. To do that, remember that we need to define a, b, and c. A is the coefficient on x squared, it's 2. B is the coefficient on x, it's negative 7. And c is the constant, it's negative 12. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Substituting in, negative b would be negative 7, which, yes, will be 7 in the end, but I'm just going to write out every single step for the moment. B squared would be negative 7 squared minus 4a, which is 2, c, which is negative 12, and that's all divided by 2a, and a is 2. Starting to work this down, negative 7, as I said before, is 7, plus or minus the square root of 7 squared is 49. Negative 4 times 2 times negative 12 is plus 96, which is all divided by 4. So I have to flip over to continue. The next step we'll do is adding 49 plus 96. So we'll have x equals 7 plus or minus the square root of 145 divided by 2. Need to take the square root of 145. It's not a perfect square, so that does mean a calculator will be useful in that. If we take it to even one decimal place, it would be 12.0. So 12 is a good enough estimate. And I need to apologize. In that step, I had that we were dividing by 2. It actually should be dividing by 4. Split this two ways. One, we have x equals 7 plus 12 over 4. The other, we have x equals 7 minus 12 over 4. So on the left here, x equals 19 over 4, which we can work that out to a decimal, be 4.75. And on the right, we get x equals negative 5 over 4, which would work out to negative 1.25. Now we have our solutions to the quadratic equation. Now we can take these and do a sign analysis on the quadratic inequality. So we'll flip over. We have our number line. We'll draw it a little longer than usual, just because we have decimals to put on, and those take up a little bit more space to write. Those two values make that inequality work out to 0. Now we need to go and check numbers in each region to see whether or not it's positive or negative. So the far left I'm going to start with -2. Plugging in -2 for x. The check's a little bit longer just because it's a more complex function, but nothing out of the ordinary. We end up with 2 times 4 plus 14 minus 12, which ends up being 8 plus 14 minus 12, which works out to 10. 10's a positive number, so anything in this region here is positive. We'll check one number in the middle. 0 fits, so I'm going to pick 0. So 2 times 0 squared minus 7 times 0 minus 12, which works out to -12. Anything in the middle here would be negative. And we'll pick a number on the right. I'm going to choose 5. We get 2 times 5 squared minus 7 times 5 minus 12. Gives us 2 times 25 minus 35 minus 12. So 50 minus 35 minus 12, which is 3, which is a positive number, so anything over there is positive. Going back to the inequality, we were looking for where 2x squared minus 7x minus 12 is greater than 0, which would be known as the positives, which exist in these two separate sections, one of which on the left less than -1.25, one of which on the right greater than 4.75. So to write that out, we would have x is less than -1.25, or, because we have two separate sections, we need two separate inequalities, x is greater than 4.75.